All right, so welcome to the weekly Auras Analytics webinar series. As usual, this program is designed for individuals who have little to no knowledge as well as intermediate users of R. Um, we if you guys already are connected, but if you're new, um, and especially for those who are going to watch these recorded versions, please follow us on Instagram and Facebook so that when you stay connected, you always be one of the first to know when we provide new content, both as part of this webinar series and as part of other recordings. Um, our goal, I'm just going to talk through these. So these are the different ways to get connected. You could send us emails. You could call us directly on our business line. You can also check us out on our website. Um, and then for those who are interested in joining the WhatsApp group that we created for content, all you need to do is send a message to this number, and then I'll add it to the group so that you can receive data sets and all other resources for those who are regularly participating. And the other thing I said, um, that our goal here at Auras Analytics is that we want to teach everyone to use functions in R Studio R. So the idea is for you to be able to do data science by programming, not just using drop-down R menus. You want to be able to do some data manipulation, reading, summarizing, and managing data. And we assume you do not have a prior experience with R. So we start from the basics and then entertain every question. So feel free to interrupt and ask me questions as usual. So, all right. So having said that, the content we are going to use today, we're going to um, do something with we're going to do some data wrangling today, and most of it is going to be based off of if-else statements. So we have in the past worked with um, different data sets. So most of you in previous series, you have learned how to use data sets to do all kinds of things. Um, the idea now is very rarely, I've said it most times, that oftentimes when you do data science, whether it's um, a lot of the things you're going to spend most of your time on is getting the data ready um, to use. And getting the data ready means doing some form of data wrangling, cleaning it up, recoding variables, subsetting the data so that you only keep the variables that you need and all of that. And there are certain handy tools that you need to have. One of the things you need to do is you want to be able to recode variables. And in recoding variables, one common approach is to use if-else statements. Share my screen. So we're going to start with um, if then else statements. So for the most part, the if else statements, you can use this to implement conditional logic. Um, so using the standard if else statements, you can implement conditional logic for single values, or you can use if else function for vectorized operations. We'll talk briefly about what those mean soon. And then for multiple conditions, you can chain if else statements, what we'll talk about and referred to as nested if-else statements. So the syntax basically for if you want to use if-else for conditional logic, the syntax basically goes something like this. If, then the condition. If the condition, and then the curly braces, you execute a code to execute if condition is true. So the first part is the if statement, and then what is the condition? So you state the condition, and then there's a code to execute if that condition is true. Then else if another condition. So another condition, what is this? So else if another condition, your curly braces, and then code to execute if another condition is true. So this is that, and then else curly braces code to execute if all conditions are false. So basically, this is the approach. This is the syntax. This is the syntax for um the if-else statements. So what you do here is, if there's a particular condition, if a particular condition is true, execute this code. Else, if another condition, execute this code. Else, execute this other code. So one common example you could do this for is, imagine if you have a data set that was collected. Some of you are, I know some of you already are collecting data with questionnaires. So imagine you collect data in the field, and then some people say their gender is, so the data that has gender male, gender female, and then gender unknown. And in the data set, you collected the data as gender male is 1, female is 2, and then the unknowns. To make your data clean, more obvious, you could decide to recode the 1 and 2s as 1 male, 2 female, and then maybe unknowns um, when it's not indicated. And so that is one place where you could use if-else statements, or you could also use it for other things. So this is the syntax. Now let's see an example of this.
Can you come again, sir?
You said?
Can you repeat, sir?
So I said, if
Please,
you,
hello, sir.
yes,
Your line 3, is it still going? Is it still continue to line 9?
yes,
Because I can do bracket.
yes, this is it. From everything is one. This is the syntax for executing the if then else command. This is just the syntax. If you execute this, nothing is going to happen. I just wanted to show you this, but we're going to practice it now, implement how this syntax works um, in real settings. So let's create a variable. Let's create a variable, and let's call that variable, let's say -5. We'll create an object called x, and let's assign it the value of -5. Now let's implement the if then else syntax here. So if x is greater than 0, we're implementing what we wrote above. If x is greater than 0, print x is a positive number. Else, if x is less than 0, print x is a negative number. Else, print x is 0. So this is my code, right? I said I created an object that is negative x, negative 5, and then I said if x is less than greater than 0, I want the output to be x is a positive number. Everything is within um, quotation marks. Else, if that's the second condition, x is less than 0, print x is a negative number. Else, print x is 0. In other words, if everything here, if everything above is false, then print x is 0. So let's guess. Look at what I have. X is a negative number. So when I run this code, what do you think the output is going to be before we run it? Which of these three options is it going to print? X is negative 5. What do you think is going to print out? Does anybody want? All right, let's run it and see. You see in my console, it prints X is a negative number. Are you surprised? No, because X is negative 5. So it's a negative number. And so the code executes based on the conditions. We said if X is less than, greater than 0, it should print X is a positive number. If X is less than 0, we should print X is a negative number. Otherwise, print X is 0. You can try this again. And so, for example, let's change this to remove the negative sign. Let's run that code and then let's run it again. So you see, the printout has changed. X is a positive number now because we changed X to a positive number. So this is one example of how you use the if then else statement. Now, the other statement we can mention, we want to use is the if else statement rather than if then else. So what happens is if else statement is used for vectorized operations, and is the alternative to the if then else statement. What this means is that it can apply a condition to every element of a vector at once. So rather than if else if, the if else is more efficient. It is a more efficient approach for vector-based conditional checks. So we move if then else to if else, which makes it very easy. So now let's look at the syntax. We will, if this is confusing, don't worry too much. When we start applying it to data sets, some of these things I'm explaining hopefully makes a lot more sense. So the syntax is basically if else test yes no. So if else test yes no. Test is the logical vector that contains the condition that is to be tested. So you have a condition, a logical vector that's going to be either yes or no, that is to be tested. So that is what the test here represents in the syntax. Yes is a vector of values to return for elements where test is true. So if test is true, what are the vector of values that should be returned? That is what is in yes. Now, no is a vector of values to return for elements where test is false. So this is the basic syntax. If test is true, return the values as yes. Otherwise, return no. Now let's see an example of this. Let's create a new variable y and let's assign it, let's say 2, 5, 8, 11. That's the variable, that's the object we have created, y. Now let's use if else. So let's create a new object and we'll call that results. So result, let's say we're categorizing.
Sorry for taking you back, sir. For the first under syntax, I get error. Object is not found.
I just told you syntax, you're not executing anything. That is just syntax basically means this is how the code works. So
Okay.
if you execute that, you're going to get an error. I'm just showing you this is the syntax for if else. We don't have an object called test, so you get an error. So now we are implementing that syntax here by creating an object that we call y, which will concatenate to have values 2, 5, 8, and 11. And now let's implement if else. What we'll do with if else is if any value of y is greater than 5, we want result to be assigned high value, otherwise low value. So that means if any values of y are greater than 5, we have assigned them as high value. Every other thing that's not greater than 5, in which case the syntax is the logical vector is false, assign it as low value. So that's this how we implement it. If else y greater than 5, comma, high value. Then another comma, low value. So you see this syntax is similar to what we're implementing is similar to what I have in line 22. So it's basically saying if y is greater than 5, we assign it high value. Otherwise, we assign it low value. Now let's run this.
So that comma is equivalent to if else. That comma after high value.
Correct, correct. That's I would say this is a more efficient approach rather than the if then else where you use all those curly braces, but we didn't have to use that here. So now let's use result. Let's print result and then see what we have. Print results. So you can see the output for your result is you can understand why, right? So your result, you have low value, high value, right? Because you basically set the condition that if y is greater than 5, result should be high value, otherwise it's low value. And if you see y, the first value is 2, which is less than 5. So it's low value. The second value is 5, which is not greater than 5. It's low value because keep in mind your syntax says, your condition says if y is greater than 5. So 5 is also considered low value because it's not greater than 5. And then, but 8 and 11 are greater than 5, and so you have high value, high value. So that is how you implement the if else syntax. The other syntax that you could also implement is if underscore else. This is the same thing, but this one is in the dplyr package. So to implement if underscore else, you get almost about the same results as the other one, but this one too also is a stricter type safe version that you use when working with data frames. So what this does, it helps you immediately take care of missing values and assigns them as null. So you don't have to worry initially about missing values when you use if underscore else statement. The condition is almost like the other one. Um, it's just basically because it's dplyr package, if else, just like before, condition true, false, missing equal null. So basically, the logical condition, if it's true, the output is true. Otherwise, the output is what is here, and then the missing conditions are null. Now, let's apply what we have talked about before to a data set. So we're going to use the if-else condition to apply to a data set. So we're creating the data set, let's call it my data set. And you know, from previous lessons, to create a data set, data frame, use data.frame. Let's call the first variable. We're going to imagine you collected data for gender, but it was coded in your survey as 1 and 2, 1 and 2. So let's enter the variable and let's call it GEND. GEND equal to, we're just generating this random data set. Let's call it rep combine 1, 2. Length out equal 100. So what I'm doing here is I'm creating a variable that I call GEND, which involves repeating values 1 and 2 100 times. Now let's create a second variable that we'll call age. Again, generating a random variable, which is, we're going to say floor. The reason we are using floor, you could do this without floor, is we are trying to round up the values so that we do not have decimals. But if you don't do it with floor, you can still work except that you get decimals. So floor, runif, random unif, we're creating 100 values of a variable that starts from the minimum value, let's say 18, and then maximum value, let's say 70. So we're creating values between 18 and 70, randomly generating values, 100 values between 18 and 70, and then we are rounding up those values. So now run it. If you run it, you see your object. Now let's go ahead, let's view this data set and see what we have. View my data set, view my data set. On my screen, you can see what we just created, right? So the first object variable is gend, which is basically 1, 2, 1, 2 repeated. I'm trying to make this very easy. And then the second one is age, which is approximation of values anywhere from 18 all the way to 70, lower than that. So those are the two variables we have in our data set, right? Those are the two columns we have in our data set. Hopefully, you should also get this in when you run the code. You should see what I'm seeing on my screen when you run the code. Now, that is the first part. Remember I said, now we want to recode gent so that it becomes more obvious that one, every place where there's one, we want to create a gender variable that one, it represents male, and
Error.
two represents female.
Hello.
Yes.
Sorry, I'm having error. Unexpected symbol. My data set assignment data dot frame bracket gent equals rep in bracket concatenate in bracket 1,2 comma
If you're
length
having
dot
error, there's something wrong. Look at the code that I wrote. Um, you must have typed something where you should not have typed it. If you see, because remember, our syntax is what you give is what you get. If there's a parenthesis that should be there and you miss it, if there's a comma, if something that's case sensitive and you don't type the right thing, you definitely what you need to do is look at the code again and compare with what I have um, typed here and then see where that mistake came in. I can share my code as in the charts. So I just shared that same code in a chat. So if you literally copy this code and run it, your error will be gone. So you need to figure out exactly where that error, what you did wrong, um, that generated that error for you. So that's part of learning R to use it. I know it can be frustrating sometimes. If you use R long enough, there are times where you think everything you have typed correctly, but somewhere, somehow, you just realize, why am I getting this error? And there are so many reasons. It might be a bug, it might
That's
just
fine.
be something that you type. Did you figure it out?
Yes.
Good. So that's part of the practice. When the code should work, you need to be sure that everything is written as is expected, and then you start running your code the way you want it. So now let's go ahead and create that new variable in our data set. We're going to call that new variable gender. So again, we'll go to my data set. So we are starting with the original data set, but we're not changing the data set name. We're just adding a new variable to it. So the piping operator, you guys know what the piping operator does. So my data set, so dplyr, okay, so before you run this part, dplyr mutate. So mutate is used to create new variables. So to create new variables, use the mutate function, and you can type it without this first dplyr part. But the reason I try to always tell you to do this is it's possible mutate is a function in a different package. So when you start prefixes with dplyr, it tells R that you want the mutate that is from the dplyr package. So that is why you create it like this. So let's call the new variable gender equal, we said it should be if else, gen equal 1, it should be male, otherwise it should be female. So if else, gen gen equals the equal sign should be double. That means if it's exactly equal to 1, we said it should be what? Male. Otherwise, every other thing If it's not male, that means it's false. It should be female. Now, before you run this code, you need, because is before you run, if you run that code, you're probably going to get an error. But the reason why you might get an error is you need, because this is from the dplyr package, you need to first install the dplyr package and then call up the library. So if you haven't installed dplyr package before, just type above that install.packages dplyr. I'm not going to run this because I've installed it before, but if you haven't installed it, just run install.packages dplyr. And then you run the library, and you call the library dplyr. So install line 37, and then you call the package dplyr. And then once you have done that, so you run both lines, but I'm not going to run it here because I've already installed it before. So, and I have dplyr running on my system. So I run dplyr package and then run my data set. Now let's view it again to see the new variable. View my data set. In this, we should have a new variable that is called gender or a new column. So when I say variable, it depends on the field you're coming from. Like I have a public health background, so oftentimes we'll call it variable. But if you're from the business field or other fields, it could be called column. So whatever it is the same thing, column variable. So let's view my data set. Aha. So now we see we have a third column.
Sorry,
Yes.
I'm having error. In view my data sets, double colon, could not find function view.
View should be uppercase V.
Okay.
All right, so you can
Okay.
see there's a third variable, and that's what we want. So everywhere there's one in gen, the third variable is coded as male. Everywhere there's two, the third variable is coded as female. So that's good. That's what we want. And so you could use this data set, obviously, to see that, okay, you have males and females and all of that. So that's good. Now, the last thing that we're going to do is, so now you are able to use if-else statements, right? Now, the next thing you're going to do is nested if-else statements. So the nested if-else statements, what are they? When you nest something, it involves basically placing one if-else statement within another if-else statement, typically in the false or true condition argument of the outer if-else. So what this does for you is it allows for evaluating multiple conditions and assigning different values based on which conditions are met. So you're placing one if-else within another if-else, depending on false or true condition arguments of the outer if-else. So what happens to your first if-else, and then the if-else that's within that if-else evaluates based on the output, whether it's false or true on the outer if-else, and then output something, and then the next if-else depends on how many nests you're going to make, continues in that order. So let's implement this and see an example. So if you if you look at the data set we created earlier, right, that age data set, we created age and we said the values of age were between 18 years and up to 70 years, right? Now, let's say you're interested in creating a new variable from your age variable, and you have 4 categories. You want anyone who's less than or equal to 25 years, you want them to be output as youths. Anyone who is between 25 and 35 years, you want them to be called young adults. Anyone who is between 35, who's between greater than 35 and less than 45, you want them to be called as older adults. And anyone who's above that, you want them to be called senior. So you have 4 categories. And to do this efficiently, you could use a nested if-else statement. So that is what we are going to do right now. So I'm going to state what we're doing. If age less than 25, I'm just showing the comments. If age less than 25, the age group should be youth, right? I'm just trying to create conditions that we're going to implement. If age is greater than 25 and less than or equal to 35, age group should be young adults. The other condition is if age is greater than 35 and less than or equal to 45, age group should be older adults. These are just comments. Otherwise, age group should be senior. So these are the 4 conditions we want to implement. Anyone who is less than 25 should be called youth. Anyone who's between 25 and 35 should be called young adult. Anyone who's between 35 and 45 should be called older adult. Anyone outside of that age group should be called senior. All right. So this is the condition. So let's implement it. Again, we are creating a new variable in our data set that we call age group. So let's go ahead. So my data set, we are not changing the data set name. We're just adding a new column, a new variable. Assignment operator. My data set, the same data set we're using, right? And then the piping operator. So dplyr mutate. So we'll call it age underscore group. That's the variable we're creating. Call it age underscore group. So we said if else. So here we use if else age is less than or equal to 25. That is the first condition, comma. We said this group should be youth. Youth. That is the first condition, right? So there's a comma after youth. So otherwise, else. So we add another if else statement again. If else, parentheses, always make sure every if else has a parenthesis. So if else age is greater than 25 and age is less than or equal to 35, comma, young adult, a comma after the young adult. Now, this is very important because where you place your commas and parentheses could determine whether you have an error or not. So be careful how the commas and parentheses come. So we've use one nested if-else statement, but we are not done yet. We have met the two conditions. The other one is if else age is greater than 35 and less than 45, right? So we're going to nest another if else. So if else again, age is greater than 35 and age is less than or equal to 45. We said these people should be called older adult. If all conditions are false, they should be called senior. So we nested two if else's within the outer if else. So the first if else is if age is less than or equal to 25, all those individuals should be called youth. And then the second if else that's nested evaluates that logical condition and say looks in the variable called age. Anyone who's less than 25 or less than or equal to 25 is assigned youth. Anyone who is greater than 25 and less than or equal to 35 is assigned young adult. And then you have another nesting within that. They are called older adults. Anyone who does not fulfill these three previous conditions, in which case, if the condition is false, then they are assigned senior. So you run that, you shouldn't get an error. And then go ahead and then let's view the data set. View my data set. You should have your new variable in there. Aha. So this is what you expect to see. So you have the variable that we started with, the two variables in the data set, which is gen and age. We use if-else statement to create gender. And then we use nested if-else statements to create age group. You shouldn't get an error. So now we can see both data, we can see both variables. Let's see a table of the two variables we created. Tabulate new variables. So let's just use the table function, the data set name, my data set $ gender, table data set name $gender. We can see in the console that for simplicity, I made it 50 males, 50 females. So that's good. So our data set, our new variable works as expected. Now let's look at the new age group variable. Also, let's tabulate that. So table, my data set, $age group. Good. So in the new data set, right, we see older adults. There were 21 older adults. There were 43 seniors. There were 17 young adults. And then there were 19 youth. So this is exactly what you wanted. And this is what you can achieve with your nested if-else statements. And then you can begin to do a lot of other things. You can determine the percentage of people in each group. So of course, 50% for the older adults, seniors, you can do your prop table to find the proportions. And then if you have other variables in the data set, you can run your chi-square test for two categorical variables. If you have one continuous variable and then these categorical variables, you can run your t-test, right? Whether independent or dependent sample t-test, and so many other things. So your ability to get your data set into a unique form that you want it to function is very important. And today we have highlighted the value of if then else and then if else statements either as binary in a binary operation or in the form of a nested if else statement. So this is where we are going to stop. At these days, I try not to overload with a lot of information. Learn something, spend some time practicing on it, and then if you have questions, feel free to reach out to me either by text or the WhatsApp group I created or email or whatever function, and then I'm more than happy to answer those questions.
Then one
So,
error.
so any questions for any of you that are
I'm having one error. Error in deep layer, mutate into brackets, double colon in argument, underscore group equals if s in bracket 3 dots, close bracket, caused by error in if s brackets, double colon, could not find function if else. Run rlang last underscore trace bracket open bracket close to see where the error occurred.
So apparently what is happening to you is you're not having there's some it says you cannot find the if else function. Did you install the library dplyr?
Yes.
So make sure your if else statement is correct or the position of your if else statement. Anyway, I'll answer your question, but I'm going to stop recording right now and then I will post this so that you guys can view this later.